Hello kiddies, let's start our today's session. Today we are going to deal with the concept, Carroll diagram and Venn diagram from Unit 3C, Handling Data. I repeat, the topic for the day is Carroll diagram as well as Venn diagram. Both these diagrams we have already learned. We discussed many different problems in connection with the concept. In today's session, we will be discussing more problems in connection with this topic, Carroll diagram and Venn diagram. Before moving towards the application level of questions, let's recall what we have learned about Carroll diagram and Venn diagram with the help of our introductory part. So we'll start with Carroll diagram, what it is, how it looks like, what is the use of it, etc. A Carroll diagram is a way of sorting objects, numbers, and shapes by their traits. So Carroll diagram means it is a way of sorting things like objects or numbers or shapes, whatever it is, by their traits. Carroll diagram looks like a table and allows people to sort data with more than two criteria way into boxes in a visual way using yes or no situation. So in the second statement, you will be getting a clear idea about Carroll diagram. It looks like a table and it allows people to sort data with more than two criteria way into boxes. How? A minimum of two, maximum of any number. So minimum there will be a two criteria, and it looks like a table inside. How in a table means into boxes in a visual way using yes or no situations. Now I will show you an example for a Carroll diagram. See this, it looks like a table where we can see many boxes with two criteria or more criteria. Here we can see pink shape and blue shapes. Whereas here it is shapes with curved lines and here it is shapes with straight lines. So a thing that should comes inside in this box should satisfy this condition as well as this condition. So it should be a pink shape and it should be a curved line, a shape with curved lines. So here you can see a pink shape with a curved lines. Now coming over to here, the conditions are or the criteria are shape with curved lines and blue shape. So the object or shape or whatever comes over here should be a blue shape with curved lines. So I have drawn here a circle. It is in blue color as well as a curved shape. Now coming over here, it should be a pink shape as well as shapes with straight lines. Now see, here it is a triangle with pink color. So it is a pink shape with straight lines. So it satisfies both these two conditions. Now coming to the over here in the last box, you can see the criteria are shaped with straight lines as well as blue shape. So the shape coming over here should be a blue shape with straight lines. So I have drawn a rectangle here. Now you understand? Now the yes or no question is where we can ask like this: is this a pink shape? Yes. Is this a curve shape with curved line? Yes. Now we can ask here: is this a pink shape? Yes. Is this a shape with curved line? No. So this is a tabular column with two or more boxes having more than two criteria with yes or no situations. Clear? Now we will move on to Venn diagram. What it is? Venn diagram is a way of sorting things according to different features. So Venn diagram means it is also a way of sorting things, but according to what? Different features. Venn diagrams are named after John Venn, a British mathematician. So Venn diagram got the name by this mathematician John Venn, and he is a British mathematician. Now I will show how a Venn diagram looks like. For example, this is a way of Venn diagram. It will be like like a minimum of two and more up to any number of circles. So Here you can see two different loops. This is one loop and this is another loop. And here you can see an intersecting part. That is, this is one loops part and this is another loops part. And here you can see a closed curve portion. So here in this part, you can write different things that comes in this particular circle. And here you can write different things that comes in connection with this loop. Now this is a portion where you can write similar thing, which means it satisfies this loop as well as this loop. For example, if I'm giving you some food items. Here it is a veg item and here it is a non-veg item. So I'm telling that about French fries, you can tell it is a vegetarian. Now about chicken, you can say it is a non-veg. Sometimes you might be getting a mix of veg and non-veg. For example, burger. In burger, you will be getting vegetable things like many vegetables will be kept inside those two bread slices. So inside that, a chicken piece also will be there. So burger is an example because it satisfies the vegetable part as well as non-veg part. So you can write here. So if it is pure veg food, you can write over here. If it is a pure non-veg food, you can write it. If it is a mix of veg and non-veg, you can write it in similar because it satisfies veggie food as well as non-veggie. Now you understand what a Carroll diagram and what a Venn diagram is. Okay, now we will be moving to our application level of test. These are all things we have discussed earlier. I just recall all these things. Let's recall. Now I just give you a time to recall what you have learned about Carroll diagram, what you have learned about Venn diagram, how a Carroll diagram looks like, how a Venn diagram looks like, how we are analyzing or putting things in a Carroll diagram as well as Venn diagram. Hope you got an idea right now. Now we will be moving to our application level of questions. Here comes your very first question. That is, copy the Carroll diagram below. So this is your Carroll diagram. Complete your diagram by placing these fractions and decimals in the correct section. These are the fractions and decimals. Now you have to place correctly these decimals and fractions in this Carroll diagram. That's a question, okay? So shall we start doing the answer part? Okay, let's start. Okay, here you can see the thing is less than 3 by 4. Here it is not less than 3 by 4. Here it is equivalent to 1 by 2. Here it is not equivalent to 1 by 2. So you have to pick decimals and fractions from this box over here, which satisfies the condition less than 3 by 4 as well as equivalent to 1 by 2. Equivalent to 1 by 2 means equivalent to 1/2. Now here you have to write the decimals and fractions which satisfies not less than 3 by 4 as well as equivalent to 1 by 2. Now here you have to place the numbers that is less than 3 by 4 not equivalent to 1 by 2. Here you have to write the decimals and fractions from this box which satisfies the condition less than 3 by 4 and not equivalent to 1 by 2. Okay. So shall we start doing the answer part? Now we will be concentrating over here. Now we have to pick out decimals and fractions which is less than 3 by 4 as well as equivalent to 1 by 2. So from here equivalent to 1 by 2 means what? 1/2. So in decimal part, this 1 by 2 is when you divide 1 by 2, you will be getting the answer 0.5. Is that a number 0.5? Yes. So 0.5 will be here. Now, less than 3 by 4. So just pick out the fractions less than 3 by 4. Less than 3 by 4, you can get 2 by 4. which is less than 3 by 4, but it should satisfy the condition equivalent to 1 by 2. So this 2 by 4, we can simplify it as 1 by 2 because in 2 and 4 goes on 2 stable. So 2 as 1 time and 4 as 2 times. So this 2 by 4 is equivalent to 1 by 2. So this 2 by 4 also here we can place. Now, what about any other possibilities? What about this 4 by 8? By looking this number, you might be thinking that is greater than 3 by 4, but actually when you simplify this, you will be getting 1 by 2. 1 by 2 means equivalent to 1 by 2 as well as less than 3 by 4. 1 by 2 means it is less than 3 by 4. So you can write 4 by 8 too. Any other possibilities? Yes, here it is 5 by 10. 5 by 10, is it less than 3 by 4? Sometimes you might be looking at the number for the first time and thinking 5 by 10 is a larger number, so it will be greater than 3 by 4. No, just look at the now fractional part and think about where any chance to make it in the simplified form. Whether these two, numerator and denominator, can come in one stable, can be simplified. Yes, 5 and 10 comes in 5 stable for 1 times 5 and 2 times 10. So this is also equivalent to 1 by 2. So 5 by 10 can also be marked over here. Any other possibilities? No, only this much. So what are the answers over here? 0.5, 5 by 10, 2 by 4, and 4 by 8. Now we will be coming over here. Not less than 3 by 4 equivalent to 1 by 2. So which means it should be equivalent to 1 by 2, but it should not less than 3 by 4. So which means it should be greater than 3 by 4. So any possibilities? We will be getting the fractional part and decimal part greater than 3 by 4. But any one which equivalent to 1 by 2? If you're taking this 7 by 8, it is greater than 3 by 4, but it is not equal to 1 by 2. 0.9, which is not equal to 1 by 2, because 1 by 2 means 0.5, but 0.9 is greater. 7 by 10, that is also greater than 3 by 4, but it is not equivalent to 1 by 2. So for here, no possibilities. We can't write any number which satisfies both the condition, that is equivalent to 1 by 2 as well as not less than 3 by 4. So nothing is there as per this given set of decimals and fractions. Now coming over here, less than 3 by 4 not equivalent to 1 by 2, which means it should be less than 3 by 4, but it is not mandatory that it should give 1 by 2. So we can write many numbers, which is you just need to concentrate only one thing. Then now you can pick out any number that is less than 3 by 4. And also keep in mind, it should not give half. Any other possibilities you can write, okay? So there you can write 0.1, which is less than 3 by 4 as well as not equivalent to half. Next, 7 by 8 is not less than 3 by 4. What about this 2 by 4? It's equivalent to half, so not possible. What about this 1 by 3? Yes, it is not equivalent to half and it is less than 3 by 4. So 1 by 3 is possible. What about 3 by 4? It is equal to 3 by 4. We need to get less than 3 by 4. So this is 3 by 4. Actually, we need to take or place numbers that is less than 3 by 4. So this is not applicable. What about 7 by 10? 7 by 10, which is less than 3 by 4. Is this less than 3 by 4? When you simplify this, you can't get any because both these numbers are prime numbers. So it will goes on that number and one stable. So 7 by 10. Okay, when you divide this 7 by 10, is it equivalent to half? No. So there you will be getting not equivalent to half. So that is 7 by 10 is possible. Now any other numbers? 0.3. Yes, 0.3, which is also less than 3 by 4 and not equivalent to half. What about 4 by 10? 4 by 10 is equivalent to Can you choose 4 by 10? Is this equivalent to 1 by 2? No, it is not equivalent to 1 by 2. So this is also applicable 4 by 10. Any other possibilities? What about 1 by 4? This is also not equivalent to half as well as less than 3 by 4. 4 by 8 is not possible because it is 1 by 2. 0.3, we already picked 0.3. Now what about 0.5? It is exact half. So we can't choose. What about the last one, 0.8? It is greater. So the possible answers over here are 7 by 10, 4 by 10, 0.1, 1 by 3, 1 by 4, 0.3. These are the only possibilities. Now coming over here. Not less than 3 by 4, not equivalent to 1 by 2. That is, it should be greater than 3 by 4 and it is not mandatory that it should be equal to half. So you can pick out all the numbers that is greater than 3 by 4. So what about this 0.9? Yes, greater than 3 by 4. 7 by 8, greater than 3 by 4. What about 2 by 4? It is half, so not applicable. 1 by 3, it is less than 3 by 4, not applicable. 3 by 4, we need actually not less than 3 by 4. So, which means greater than 3 by 4. So, this is not applicable. What about 7 by 10? 7 by 10 is not applicable. What about 5 by 10, which is 1 by 2? So, less than, or it is equivalent to half. So, not possible. What about 0.3? It's a smaller number. 4 by 10, it's a 4 by 10 means what it is, like 2 by 5. So that is less than, so it is not possible. 1 by 4 smaller number. 4 by 8 is exact 1 by 2. What about 0.5? That is also equivalent to 1 by 2, so it is not applicable. 0.8, yeah, it is a larger number, so we can write over here. So this is how you will be writing this answer. So your Carroll diagram will be looking like this. Okay. Very simple thing. You need to choose that these two conditions should satisfy the number writing over here, and the number writing over here should satisfy this condition as well as this condition. Now here, the numbers or whatever you are writing over here should satisfy this one and this one. And the last box should satisfy the condition like this and this. Very simple question. Just look at the conditions or the criteria given and think whether these whatever things you're writing over there satisfying those two criteria. If it is satisfying, you can write it over. If it doesn't satisfy one and satisfies another also, you can't write it. It should satisfy two. Okay. So hope this is clear for you. Now we will be moving to the second question. Okay, look at the Venn diagram. The green circle for multiples of 6 is inside the blue circle for multiples of 2. This is because all multiples of 6 are also in 2 times table. But there are some numbers inside the blue circle but outside the green circle. This is because not all the multiples of 2 are in 6 times table. For example, 2 and 28. Numbers have been written in each section of the diagram. Check that the numbers are in the correct place. Actually, don't get panicked by seeing a essay type question. Nothing is here. Actually, our question is check that the numbers are in the correct place. This is just a statement or an example they have given you. Sometimes this can happen like that. Now, our question is to check that the numbers are in the correct place. Okay, now shall we start doing the answer part? Okay. Our thing is to check this Venn diagram and just conclude whether it is correct. It is placed correctly, or if it is any wrong, just find it out. Okay. So here the blue circle resembles multiples of 2. So whatever things are written inside the blue loop should comes in 2 times table. Now the green one is like multiples of 6. So the green loop, the number that comes inside the green loop should satisfy that the numbers are multiples of 6. And this purple loop resembles multiples of 7. Now, here you can see an intersection. That is an intersection of multiples of 7 as well as multiple of 6. So whatever number comes over here, it should satisfies the condition that it is a multiple of 7 as well as a multiple of 6. Only this much. So let's start with the blue loop. So blue loop means multiples of 2. And the numbers are 8, 4, 2, 14, 28. Is 2 a multiple of 2? Yes. What about 4? It is a multiple. 8? Yes. 2 4s are 8. What about 7? Yes. 7 2s are 14. What about 28? How many times? Is it divisible? Yes. 28 comes in 2's table, or else you just divide this 28. You will be getting the quotient as 14, which means 14 multiplied by 2, you will be getting 28. So the blue loop is exactly perfect. All the numbers written inside the blue loop are multiples of 2. Now coming over to the green loop, that is multiples of 6. What about this 18? Is it a multiple of 6? Yes. 6 3s are 18. Now what about this 12? Is it a multiple of 6? 6 2s are 12. What about this 42? Is it a multiple of 6? 6 7s are 42. So yes, this one is also perfect. Now what about this purple one? Multiples of 7. So the numbers written over here is 42, 40, 28, 21, 20, 35. Now just check 14. Yes, it's a multiple. 7 2s are 14. What about 21? 7 3s are 21. What about this 35? 7 5s are 35. 28, 7 4s are 28. 42, 7 6 are 42. So it also satisfies. That is, all the numbers inside the purple loop satisfies the multiples of 7. Now what about this one, the intersection part, 42? It should satisfy the 2 condition. That is, it should be a multiple of 2 as well as a multiple of 6. Then only the entire Venn diagram will be correct. 42. Yes, it's a multiple of 6 as well as multiple of 7. 7 6 are 42, 6 7s are 42. So everything is correct. So what you can conclude? The numbers all are in the correct place. Clear? This is a Venn diagram. They have given everything. You just need to just conclude whether it is correct or not. If it is here in this situation, everything is correct. So you just need to write the numbers all are in the correct place. Suppose anything is wrong, you need to mention this one is exactly in the wrong place. It should be comes in that particular place, and you have to point out all those things. Now here everything is perfect, so we just need to write only this one. The numbers all are in the correct place. Okay. Next comes the third one. Draw these Venn diagrams and write 2 numbers in each section. Don't forget that the areas outside the hoops is also a section of the Venn diagram. Okay, so these are 2 different Venn diagrams. The one we discussed just before, there they have given the numbers and asked us to find out whether it is correct or not. Here they have given 2 different Venn diagrams and you need to write. You need to write numbers that satisfies all these conditions. See, here you can write any numbers. That is up to your choice. Only the thing is it should satisfy. For example, multiple of 2. So you can write multiple of 2, that is 2. Multiple of 4, you can write a number, that is 4. Multiple of, here it is 9, so that is 9. Multiple of 9, yes, the 1 9s are 9, so that is enough. Now here, it is an intersection part. That is, it should satisfy a multiple of number and multiple of 4. So here you have to write a number that should comes in 4 times table as well as 9 times table. So just think out which is a common number. Yes, 9 4s are 36 as well as 4 9s are 36. So 36 is a number that comes in both the multiples. So this way you can write over here. Now just see, here it is a multiple of 3, multiple of 6 and multiple of 5. Multiple of 3, you can write a number. Any number that comes in 3's table. For example, 9. 9 is a multiple of 3. Now multiple of 6. You can write a number 36, which is a multiple of 6. 6 6 are 36. Now, multiple of 5. Any number you can write 10. 10 is a multiple of 5. 5 twos are 10. Now, here it is an intersection connecting the multiple of 6 as well as multiple of 5. So just think about a common number that comes in two different tables, that is multiple of 6 as well as multiple of 5. So what I'm going to write over here is 30. 5 6 are 30 as well as 6 5s are 30. So this is my way of writing this or completing this Venn diagram. You can write any number. It is not mandatory that what number I give you need to write. You can write any number. Numbers are up to infinite. So you can write any number, but the thing is it should satisfy the conditions that given in the Venn diagram. So here the answer part looks like this way. Okay. Here I have written many numbers. So in that way you can also write many numbers. Now see, outside I have written some different numbers. While writing the numbers outside this loops or hoops, you have to think that the numbers that you are writing outside should not satisfy multiple of 2 or multiple of 4 or multiple of 9. See, I have written over here 1. 1 means it doesn't comes in 2 stable, 4 stable or 9 stable. It comes only in 1 stable. What about 3? It is not a multiple of 2, it is not a multiple of 4, it is not a multiple of 9. So you can write any number outside these circles, which means that number does not satisfy these criteria. Here I wrote about 2 and 7. So 2 is not a multiple of 3, not a multiple of 6, not a multiple of 5. 7, not a multiple of 3, not a multiple of 6, not a multiple of 5. For example, here you can write the number 11. 11 is not a multiple of 3, not a multiple of 6, not a multiple of 5. Here also you can write any different numbers, which means that number does not come in any of this table mentioned inside the Venn diagram. Okay, clear? So you can write another numbers, okay, while writing this question in your notebook, or by working out these type of questions. You can do this in your notebook itself. 2 more parts are there in your textbook. So you can write the C part and D part. Where that, just try to do it by yourself. Okay. Now here comes a follow-up activity for you. Copy this blank Carroll diagram. Choose your own categories and fill this Carroll diagram. Here I just given you a blank Carroll diagram. No criteria I have given. You can fill this Carroll diagram as per your idea, which means you can fill this in connection with numbers or shapes or fruits or vegetables or whatever thing, costumes or dress type, anything. If you want to make it like a combination of cricket, football, whatever it is up to your choice. The thing is, you need to complete this Carroll diagram. The criteria and the categories is up to your choice. It is up to your wish, or it's up to your likes and all. So do this in your math note and share it via class dojo. Okay. Now with this topic, we came to the end of our grade 4 portions. In your Cambridge Learner 4 math textbook, we completed all the concepts through this video session classes. Now for the rest of the classes, rest of the video sessions, we will be doing worksheets. We will be discussing those worksheets, and you can message me your topics that you feel difficult or you need much more explanation, all those things. So for the coming video sessions, we will be doing worksheets. I will be sending you the worksheets along with the video. We will be doing like revision classes. I will be revising unit wise or topic wise. That is on behalf of the time and all. Sometimes I will be taking a whole unit, or else I will be dividing a unit like a half each, and I will be giving you worksheets so you can do it. And I will be providing answer key in the next video session. So you will be getting many questions to practice and make thorough about all the concepts and all. Okay. So That's all for today. Thank you.